We will now consider the last sorting algorithm that we have seen before, which is heap sort. Okay, and this is by far the more involved one, the more lengthy version of sorting that we have seen so far. Okay, so we will do it slowly and we will do it step by step. Okay, it will take some time, but that is okay. Okay, so on the side you also have these lecture slides, okay, which we used during our lectures, so that well, you may not be able to follow everything because the slides are shown in small size, but at least you know which slides to look at in case you want to refer back to these slides. Okay. So in heap sort, what was the idea? So if you want to sort an array in descending order, we have to first build a heap. Okay, and a heap is just a binary tree with as many vertices as there are elements in the array. And we fill the elements of the array into the vertices in a way that we have this heap property, max heap property, right? So the parent value will be greater than or equal to the value of the children, right? That is why we do these transformations. Okay. Once we build heap and the heap is ready, at the end of the build heap, we have a binary tree with the heap property. And now we get the sorted array by simply removing elements from the root, from the top, and then what is called heapify. Okay, we heapify. For instance, here we take the top element out, top element 60 out, and then there is a blank, and then we have to move elements up in a certain way so that at the end only one of the leaves is left out, which we can throw away. And then what remains is again a binary tree with the heap property. Okay, and then we repeat this. So that is the heapification thing. And then each of these values in that particular order, this will go on building our array in sorted order. Okay, so finally what you get will be the sorted array. And the runtime of heap sort we have seen is n log n. Okay, build heap is n log n, sorting is n log n. So total heap sort takes runtime n log n. Okay, so let's go with this step by step. So what are we given? So given an array, let's say 1 2. Okay, the first thing that we need to do is to build a tree out of this, right? Build a heap out of this. Now, in order to do that, one first needs a tree structure, and then you build the heap. Okay, so that's the thing. So the first algorithm that you need is simply create. So let me not say create. Let me just say binary tree. The parameters are just n. What does this do? Okay, so this simply creates a binary tree of size n. Is that okay? So that is what this is. Now let me not fill this. Let me keep it this way. Let us go ahead. Okay, let us go ahead and see which all programs do we need. Okay, there are multiple algorithms and we put them all together in order to get this thing, right? So binary tree n will return a tree. Okay, so at the end of this, there will be a return statement. It will return a tree t. Okay. The second thing is we have to take this binary tree t and fill the values of a in the build heap fashion. Right? So that is what we have, build heap, and now the parameters are the tree and the array. Okay, the tree and the array, and we fill the values of the array in the tree in the fashion so that we will have the heap property. Okay, so that is what build heap does. So once again, we will fill the details a little later. Let us just look at the structure of this program. Okay, so there is a start, there is a stop. Somewhere at the end, we will return the tree t, but now the t will have the values filled. The values of a will be filled in the heap fashion. Is that okay? So that comes to the end of this part. Okay, then therefore we have reached here. We have reached this build heap part. Is that okay? Now the next thing that we need to do is something called pop and heapify. Okay, what does that mean? So we have to remove the top element from the tree and then heapify this again, so that heapifying is basically rearranging these elements so that the leaf gets cut out, and you are left with again a smaller binary tree with the heap property. Okay, so that is heapify. All right. So that is a single operation for now. Okay. So one of these steps, we will do these multiple times, but a single step, you for one value removal, let's call that pop and heapify. Okay. So that is another program called pop heapify. What what are we doing? It's taking the input only the tree T. It will already have all these values and we can do all the things. Okay. Pop heapify. Is that fine? So once again here, there will be start and stop. And what are we really returning? So we are returning a value here. Okay. So return a value at the root, a value at the top. Okay, so that is top value. Is that okay? So that will be a variable. Return the top value. All right. And now comes the final heap sort algorithm. So what does the heap sort algorithm do? Now we can write down the structure of heap sort algorithm. The heap sort takes the array A, and then what does it do? We have to output an array in the sorted fashion, right? It has to be a sorted version of the array A. So we have start, we have stop, right? What is the first thing we do? First thing is we have to create the binary. So we will use these things. Okay. So T is equal to binary tree of what length? Length is as many elements as there are there in A. So A dot length. That is the first thing. Okay. Once we do that, what do we want to do? This is simply an empty binary tree with values are empty. Okay. The binary tree structure is there. How will we do that? Well, we will create a binary tree using a linked list. We have already seen that before. Okay. We have used it via linked list. All right. So that is something we have done. So T is a binary tree with as many vertices as there are elements in A. Okay. What now? Now we need to fill the values of A in T. Okay. So that itself will be the output. So T equal to build heap T comma A. You understand what is happening here? We take the empty tree T. Empty in the sense the values are not there. Then the values come from A. We will build heap in this form and it returns a tree T, right, with filled values. That is now T itself. Okay. So we are putting it back to T. Is that all right? So now the tree T is built. Okay. Now what do we need to do? Now there isn't much. Now just the simple sorting part remains. Okay. So the sorting part is, so let's create an array for the sorted version of A. So create B 1 to, let's say A dot length. Okay. And successively we have to pop the top element of the tree and heapify, right? That's what we have to do. So for I equal to 1 to A dot length, simply do this. B of I is equal to pop heapify T. What does that do? So I equal to 1, it will pop the tree, the root value, the top value goes into B of 1. Then it will heapify. Then I equal to 2. Now the root value in the remaining tree, that will become the second value. That will become B of 2. Then again heapify. Then in the smaller tree, the root value, the top value, that is now B of 3. Okay. So as we have seen before, when we do this, this is the array that is getting growing here, right? Step by step, that is the array B. Okay. So the first value that enters will be the maximum value. Second value that enters will be the second maximum. Third value that enters will be the third maximum. Fourth that enters will be fourth maximum, and so on and so forth. Okay. So B at the end of it will have all the elements of A in sorted form. So end for. That's it. Okay, that completes sorting, and then we just have to return this. So return B. Is that all right? So that is it about heap sort. So that is the basic structure. Once again, let me recall. Let's revise this once again. So what all do we need? So we are given an array and we need to do heap sort. In order to do heap sort, we need a binary tree structure with as many vertices as there are elements in the array n. So we will use n as a parameter and first construct a tree T. For that we have this function. Okay. Then comes filling the values of A into the tree and creating the heapify property. The heap property we call build heap. So we will pass the tree, the empty tree, the array, and then do some work, and the return value will be the tree with the heap property. Once that is done, what is one instance of an element popping out? Well, we pick the value that is at the root here. So at the end of build heap, we pick the value that's at the root here, we throw it out, and then again heapify, right? So that is what this does. This will pop out the value at the top and then heapify and get a smaller tree. So the top value is what gets returned. Okay. And what is heap sort? Heap sort is a combination of all of these, right? So given an array A, we now need to sort it using the heap sort algorithm. So we first create a tree T using the binary algorithm, which you have just seen. Then we will build the heap T using the empty tree T and the array A. Once that is done, we are ready to start sorting. So we create a new array for storing the sorted version of A, which is B of size A dot length. And now successively from I going from 1 to A dot length, we are going on filling B of I, B of 1, B of 2, B of 3, and so on. How is that? By successively popping. So B of 1, pop T, pop PP5T, that is B of 1, right? Now whatever remains, B of 2, pop PP5T. Now whatever remains, B of 3, pop PP5T, right? Keep on doing that. Is that okay? So finally, the array that will be built is B, and that will be in the sorted form. Okay, that will be the sorted form of A. So that completes the heap sort basic structure. Okay, basic structure of the heap sort algorithm. Now these smaller algorithms which are there, we will fill it, and I'll continue that in the next part of this video. Okay, so we'll stop for a moment.